last day of notes plus clarification. Okay, so we talked about how for every standard deviation we move in x, the predicted y will move our standard deviation in the y direction. Okay, and this is a picture where it's been standardized, and this is where we left off. So far we've been working with standardized values, so this would be the equation of the line of best fit. Okay, basically it's y hat equals mx plus b, where b equals 0, or we could be more AP stats with that and say that it's y hat equals b sub naught plus b1x, where b sub naught equals 0. Okay, so that's just rewriting it, y equals mx plus b. Okay, and again, we've standardized it. We've taken the z-score for every data point, so it's actually, right here would have been x bar, y bar, and then you've got a line going through it. Okay, and what this is a derivation to show how we get our different values when we have you plug stuff in. So you could take the formula for z-scores and put the z-score for y and the z-score for x into the formula. And then right here, this is the point slope formula. Remember, y minus y1 equals m times x minus x1. And since we know that the only point that it has to go through, the line of best fit has to go through, is x bar, y bar, that's right there. And we've also learned that the slope of the line of best fit is r times the standard deviation of y over the standard deviation of x. Okay, this last little bit is just showing you how you could solve for it. So they go ahead and they distribute the slope and get down here. And you know what, I really just don't think the rest of that derivation is that necessary. Although what it is showing you is that, again, your slope is this. Okay. The whole point of this is to solve problems like in your homework on page 198, number 46. So I'm going to do one for you here, and then you should be able to do the homework. And what we're going to do is we're going to use the formula. And then what they can do is they can give us the x bar, the y bar, the s of y, and the r, and the s of x, sorry, all of the pieces to fill into the formula and find the best line of best fit. So what we have is y bar equals, y hat minus y bar equals the slope, which is r times s of y over s of x times x minus x bar. So this is actually just a plug and chug activity. This was a kind of scary looking derivation, but we're using it just to plug and chug. So then it's saying, okay, let's plug in our x bar right here, our y bar right here. We can plug in our r for s of y and our s of x, and solve for the least squared regression line. So I'm going to do that. I've got r y bar minus 150 equals our r of 0.62 times s of y, which is 30, over s of x, which is 4, times x minus x bar of 65. Okay, simplifying that, I get y bar minus 150. Multiply this stuff to get together, and I get 4.65 x minus 302.25. And what I did there is the 4.65 is all of this. And the So 2.25 is 4.65 multiplied onto that, 65. So I just distributed. Lastly, we can add 150 to both sides, and I get a y bar equation, or y hat equation, least square regression line of 4.65x minus 152.25. So this is exactly how you would do problem 46 if you haven't been able to do it. Just a couple notes. Note, unlike the correlation coefficient, x and y are not interchangeable. This is some last information unrelated to what we just did when calculating the least square regression line. Therefore, we should never use a y value to try to predict an x value. You might actually get the same linear regression line, but the r's will not be the same. Note, if r equals 0, and the slope equals 0, and the least square regression line is horizontal, so there's absolutely no linear association. Knowing x won't help us predict y. So that's this first part of the lecture. The next part is the clarification. Okay, clarification lecture. I've just gone ahead and put the whole unit on this page, and you can print it out in the module. But it reminds you that the explanatory variable is the x, and the response variable is the y. When we talk about association, we're talking about direction, form, and strength. Okay, and we're using usually R, so positive and negative, and then is it mild, moderate, or strong? These are our four things, 1, 2, 3, and the fourth one is outliers. And outliers can be important or not, whether they have leverage or if they're influential. Remember, a leverage point is an outlier in the x direction, and it affects the equation in the residuals. An influential point, basically, if you admit this point, it leads to different results. It can even change the slope. Okay, and again, correlation is what we use to discuss strength, and this is how you interpret correlation. There is a positive or negative, and then this would be like mild, moderate, or strong association between the x and the y. You put the context in. There are also key parts of the regression model. Okay, slope. For every one increase in whatever the y variable is, the x variable increases by however much the slope is. Okay, we've got stuff about the y-intercept. Beware that if our data points are not close to x equals 0, our y-intercept can make no sense. Another big thing is that the point x bar, y bar is the only point that must be on the linear model. R squared, okay, that's the coefficient of determination, and it gives us the fraction of variability of y accounted for by the least square regression line, and we use it like this. Let's say our R squared was 0.72. We'd say approximately 0.72% of the variability in, maybe we're talking weight, can be accounted by the variation in height, something like that. You need to memorize these blue areas, okay? How you interpret your results, because that's what stats is about. We've also learned about S of E, which is the standard error, or the standard deviation of the residuals, and it can be found by this. Again, this top part here, you can find the residuals in the calculator, put them in list 3, and then do one variable stats to get the sum of the residuals. And I shouldn't use x bar because that's what you get in the calculator, but it would be the sum of the errors. Okay, and then you interpret that on average. The observed, maybe we're talking about this thing again, the observed weight. Weights are maybe 22 pounds, if that's what we found S to be, from the predicted weights. So this is just kind of a review of what we've discussed. Also, we can standardize all data points by finding their z-score. Then the line of best fit becomes, we talked about a minute ago, where the slope is r and the y-intercept is 0. By analyzing this, we can see that for every one standard deviation, x is above the mean x, the y value is r standard deviations above the y mean. It works the same way if we're below. And then we can use what we just saw, this formula, to find the least square regression line if we know all the pieces. Now let's talk about leverage and outliers and influence.